All right, so now for example number 6, we're given the rational expression 5 over x plus 3 over x minus 1 is less than 0. Okay? Now, what we would normally do is we need to solve this thing. And the way that we solve it is we have to find a common denominator. I can't solve it the way that it is. All right? So we're going to do this just like we did 2.7. The common denominator is going to be x plus 3 times the quantity x minus 1. And so Mr. Adams has been kind of doing a shortcut. I don't know if that's good or bad. What I really should have been doing this whole time is taking this whole inequality and multiplying it by the quantity x plus 3 times x minus 1. And so when I distribute that through, I've been kind of skipping over things, but that should go through here, and go through here, and go through here. So what that looks like is x plus 3 times x minus 1 times 5 over x plus 3 plus x plus 3 times x minus 1 times the quantity 3 over x minus 1. Okay? Is less than, and then we're going to do the same thing, x plus 3 times x minus 1 times 0. Now I wrote it out completely, and I kind of skipped this step, and I thought about it as I was watching the videos, and I said, well, maybe they don't understand what Mr. Adams is doing. Maybe it would be better if I write it all the way out so you could see. When I multiply this first term, this is going to cancel with this. Okay? When I multiply the second term, this is going to cancel with this. This whole thing is going to equal 0. So on the next line, what I have is 5 times the quantity negative 1 and times the quantity 5x. So before Mr. Adams says the denominator goes away, don't have to worry about it. Well, that's true. It does. It literally goes away, but it cancels out with the common denominator. And so I end up with 5x minus 5. Over here, same thing. This 3 gets multiplied by this 3 and gets multiplied by this x. So I have positive 3x plus 9 is less than 0, because 0 times all this stuff is just 0. Okay? Well, now I have something that I can solve. And so when I combine like terms, I have x, 8x, right? This plus this. And then plus 4, which is this plus this, is less than 0. And double check that, make sure we're doing that correctly. Now, if I solve this, when I move the 4 over to the other side, I get x is less than negative 1/2. Now, I don't know if you guys realize this, but this is the exact same problem that we had before. Okay. So now what would this look like graphically? What values could I plug into the original equation that gives me all this? See, there's one thing that we've almost forgotten. Originally, I had this and this. So I went through and algebraically solved this. And when I say solved, I found a value for x that makes the statement true. But then I have this other issue of undefined fractions. Okay? And so since I have undefined fractions, that means when I get way down here, I also have to consider that x cannot equal -3 and x cannot equal +1. God bless you. Now, Mr. Adams did this a little differently than what the textbook had done. Basically, what I have, if I were to do this problem differently, and let's do it on the other page, if I had 5x over x plus 3 plus 3 over x minus 1 is less than 0, and I just worried about my common denominator, and I multiplied this by 5x, 5 times the quantity x minus 1, and then I did the same thing over here, and I said x plus 3, like we did before. Well, on the top, I still would end up with 8x plus 4 all over the quantity x plus 3 times x minus 1. So algebraically, when Mr. Adams did it the other way, I was able to eliminate the denominator. But if I were to do it this way and combine like terms, this is what I would get. Now, I could do this. I could factor out a 2 and say 2 times 2x, or no, let's factor out a 4. That would work better. If I were to factor out a 4, I would get 4 times 2x plus 1 all over x plus 3, x minus 1 is less than 0. Now, when I do it this way, I could factor out a 4. In other words, I can multiply this by 1 over 4, and I can multiply this by 1 over 4. This 4 cancels with this. I get 2x plus 1 all over x plus 3 times x minus 1 is less than 0. Now, does that look familiar? It's example number 5, isn't it? So, what does that mean? Well, if I come in here and I graph it on my graphing calculator, it's the same graph that we had before. See, the statement is wanting to know what values of x is going to make this thing less than 0 or negative, right? That's what it means from a little more formal perspective. And so, let's graph that. So if I come in here and I graph that function, and I say 2x plus 1 divided by the quantity x plus 3 closed times x minus 1, close the parentheses, and I graph it, That's the graph that we had last time. Right? So this is the function from example number 5. And so what we're really looking at, let's use red. We want to know when f of x is less than 0. Well, that means this, those two scenarios. Now, algebraically, if I go back and I look algebraically, what I said was, when I did it algebraically, I just said when x is less than -1/2. So why would Mr. Adams do the problem that way? Because you'll probably do the problem that way. Would you be correct had you done the problem that way?
Yes.
Not really. Look at what I'm saying. Okay? I'm sorry, I'm not trying to call you out or anything, but it's a common mistake. So what we're saying is, if we go back, whoops, I gotta put this thing. If we go back, I solved this. I did a lot of algebra. Okay? Not one algebraic move was illegal. I did everything mathematically correct, and I got this answer. Right? And then I even went and I redid it a different way. And the bottom line is that I can't ignore this, and I can't ignore this. I can't ignore it. It has an impact on how the graph is. Algebraically, I could get rid of those things, but originally they're there. So what I need to do then is I need to figure out a way to make sure my answer is correct. This is what I got just using algebra. And I really didn't make any mistakes other than the fact that I forgot that the original fractions were defined by vertical asymptotes when they were undefined. Okay? When x equals -3 and when x equals -1/2. But my algebraic solving, my algebraic manipulation said that x was less than 1/2. This is not true. So when it's less than 1/2, this little section here is positive. Right? It's not until I get to this vertical asymptote. So why am I showing you all this stuff? And what does it mean for you? It means that you should probably graph things first. It means that you can't just solve algebraically. It means you got to think. You got to use your head. You got to remember about the domain restrictions. You got to remember what the original equations are. You have to remember to graph it. You have to remember to do the sign test. Truthfully, I did make one little mistake. It was a procedural mistake. Truthfully, and this is how it was written in the book, I should have never left it like this. So the point that I'm trying to make is that when you do an inequality, just wait 1 second. When you do an inequality, you have to treat it like an equal sign and then do the sign test.